So hello everyone. In this video, we will solve one problem on elastic sorting loss of post-tension section. So problem is already given here. Let us go through the problem. A post-tension concrete section of 200 into 400 mm with three pre-stressing tendon located at an eccentricity of 50 mm given. Okay. So a cross section of 200 into 400 is given in three pre-stressing tendon with an eccentricity of 50 mm. Area of pre-stressing steel Area of pre-stressing steel is 50 mm square and the stress in them is 1000 Newton per mm square. Calculate the amount of elastic shortening loss if the tendon are pre-stressed either simultaneously or sequentially. So we have to find out the elastic loss when they are stretched simultaneously and when they are stretched sequentially. Okay. Now let us note down the given data. The cross section is given as 200 into 400. Eccentricity of the tendon is given as 50 mm. Area of pre-stressing tendon 50 mm square, and we will take the model ratio value to calculate the losses as m equal to 6. Okay. Now let us calculate the basic that we will. The area of the cross section we can easily calculate, that is 200 into 400, 8 into 10 to the power 4 mm square. The moment of inertia of the section bd cubed by 12. B is 200, B is 400 mm, and by this formula we will get a value of 1.066 into 10 to the power 9, and the stresses in tendon is given as 1000 MPa and the area of steel is 50 mm square. So by multiplying these two values, we can calculate the amount of pre-stressing force in the tendon. And if we multiply them, we will get a value of 50 kilonewton. Okay. Now we'll see the cases. In the first case, they are asking us to calculate the amount of elastic shortening loss if we stretch the tendons simultaneously. And in the theory section, we have studied if we stretch all the tendons simultaneously, that is, if we stretch all the tendons together, there will be no loss because they will act as one member. So for simultaneous stretching, there will be no loss due to elastic shortening, but there will be losses for sequential stretching. Okay. Now let us see the cases for sequential stretching. Now in sequential stretching, we have to find out the stress in concrete at the level of tendon. We can simply use the stress concept formula, that is P by A plus PE y by I, and here y is the distance of tendon from neutral axis, and that we can see is 50 mm, and eccentricity also is 50 mm. E is 50 kilonewton, is 8 into 10 to the power 4 mm square, I equal to 1.066 into 10 to the power 9. So by putting all these values, we will get a value of 0.7422 Newton per mm square. Now comes the interesting part. Now we have to find out when we cut the tendons what kind of stresses, elastic shortening loss that we experience. Now let us draw three tendons. Now when the cable 1 is cut, there will be no loss. When the cable 1 is cut, the concrete section will shorten. But since we record the pre-stressing force for post-tension section after the shortening, we will not record the loss due to elastic shortening. So we can say there will be no loss when the cable 1 is cut. But again, when we cut the cable 2, again the concrete section will shorten. And this time around, when we record the pre-stressing force, it will be much lesser compared to when we have calculated after cutting the cable 1. So we'll experience loss in the cable 1, and that value we can calculate by this formula m into fc. Fc is 0.7422 and 6, and m equal to See, so the loss in table 1 will be 4.45 Newton per mm square. Now, if we cut the third tendon, both first and second tendon will experience losses due to elastic shortening, and the value can be calculated same as m into fc. So similarly, we can calculate the loss in cable 1 will be 4.45, loss in cable 2 will be 6 into 0.7422, that will be again 4.45, but the loss in cable 3 will not occur, so the loss in cable 3 will be 0 mp. Okay. Now, one thing you have to notice that cable 1 experiences losses twice, during the cutting of second tendon and during the cutting of third tendon, and the second tendon only experiences loss due to elastic shortening during the cutting of third tendon. Okay, so when we are calculating the final stresses, we have to keep this thing in mind. Now, if we are summing up all the stresses, the total loss is cable 1. We have seen in the cable 1 we will experience loss twice, so we can simply add them. We get a value of 8.9 MP, and loss in cable 2 will be 4.45, as it only experiences loss due to cutting of third tendon, and the third tendon doesn't experience any loss. Okay, the last tendon will never experience any loss in post tension section. So if we add them together, the first tendon 8.9, second tendon 4.45, and third tendon experiences low loss, and by dividing it by 3 we can calculate the average loss. The average loss in each tendon will be 4.45 MP. So the understanding of sequential stretching is very important to calculate the losses in each cable. Okay, to calculate the average loss, finally we can add the losses in all tendons and divide with the number of tendons.